Hello class, and welcome to lesson 4.1, vertex form of the quadratic. All right, so again, you've got a handout. Again, today we're going to be using technology, which is the TI-83. But in order to do most of this stuff, you could just use any online graphing app, either on your iPad or on your cell phone or on your computer. I like the TI-83 because it actually produces a graph and a table for you. And we'll be filling in some information a little bit differently than what we did last lesson. So today we're focusing on all quadratics, and we're going to take that lovely parabola that we took a look at, and we're going to learn how to shift it left and right and up and down and stretch and compress it and maybe even flip it if we're lucky. So stay with me with today's journey. It might be a little bit of a longer lesson, but I'll try to make it as quick flowing as possible. All right, so the first thing we're going to do is start with our basic parabola. This is the one we explored in last day's lesson, y equals x squared. Okay, so I'm going to write that in. It's going to be x squared, and I'm going to graph it. Okay, so it gives me a lovely graph there. I'm going to press second and graph. I'm going to take a shortcut here today. Hopefully this will work. And I'm going to try and cut this out, bring it into my lesson. Hopefully it worked. Let me go back there and try that one more time. See if it works this time. Should be there. Maybe it's not. Let's see. It's cutting it. It's not bringing it in. I apologize. Maybe I'm not going to use this function. All right. I guess it's not working. Should I give it one more time, guys? Think I can do it? You think third time's a charm? All right, let's try it one more time. So I take this, I chop it, should go snap. Now I hear it. Something didn't work last time. Okay, so I'm going to take this. I'm just going to bring it right in here. So there's my table. Okay. All right, ladies and gentlemen. And for my graph, I'm just going to do this quickly. So I'm going to go 2, 2, -2, -2, x and y. And for your basic parabola, ladies and gentlemen, I'm going to start at my vertex, which is the turning point that we learned last day. And I'm going to teach you a step pattern. I'm just going to teach it to you right away. We'll be developing it right here. But the step pattern that I want you to develop, and you write it up here, that'd be great. Okay, it's going to be whatever a is, that's the number out front of the quadratic, times 1, 3, and 5. Okay, and I'll show you in a minute why we get that. Okay, so ladies and gentlemen, a is the number out front. In this case, it's a 1, right? Okay, and so let me see if this will get off that thing there. Here we go. Okay, and we're going to do the step pattern. So if a is 1, it's just going to be 1, 3, 5. You're like, what the heck is that, Miss R? So pay attention. From the vertex, I'm going to go over 1 and up 1. Okay, as the patterning says. Then I'm going to go over 1 and I'm going to go up 3. 1, 2, 3, which is that one. And then I'm going to go over 1 and up 5. 1, 2, 3, 4, 5. Okay, because the vertex is the turning point, I'm going to do the same thing on the other side. Go over 1, so this time I'll go to the left 1 and up 1, over 1 and up 3, and over 1 and up 5. That is exactly the same points that we have here. If you're wondering why that works, if I take a look at the first differences here, it's going to go 5, 3, and 1 towards the vertex. Likewise, if you do it the opposite way, it's going to be 5, 3, and 1, but they're going to be negative. That's okay. Don't worry about that right now. Okay? All right, so we've got our vertex drawn. We're going to write in our equation y equals x squared. Okay, and now we're going to answer some questions. The vertex is going to be our ordered pair 0, 0. Okay, direction of opening, hopefully you see it's opening up. Okay, and the step pattern, as we go over 1, we're going to go up 1, over 1, up 3, and over 1, up 5. We'll always be going over 1. It's just what happens after we go over 1. Okay, so it says here, since all parabolas have the over steps the same, we usually refer to these as the step pattern of the parabola. So the step pattern of the parabola is a times 1, 3, 5. You will want that. That's going to be your shortcut way of graphing a line. All right. Okay. says down below, we will now graph parabolas of different equations and compare the new ones to this basic parabola. So maybe we should write down here, I'm just going to erase that one, and put down basic parabola. So we're going to shift things left, right, up, down, stretch and compress this parabola. All right, let's take a look at our next example. Investigation 2. Okay, so we've got x squared and then plus 2 at the end. What do you think the plus 2 means? Well, let's go to the graph and see, graph and calculator and see what it does. So I'm going to go to y equals. I'm going to leave my base function in y1, and I'm going to change and put the second one in y2. So I'm going to go x squared plus 2. Before I graph it, I'm going to just change the line so it looks thicker, so you know exactly which one we're talking about. All right, so let's graph this. There's the first one and the second one. So what do you notice has happened to the parabola, ladies and gentlemen? It has done what? It is shifted up 2. Cool. So let's go back to our lesson here. And we notice it's gone up 2. I also want you to recognize in the equation a, which is in front of x squared, a still equals 1. So that helps us with our step pattern. Let's go back and borrow the graph. So we'll just take the graph from here. That's working now, as I can hear the snap sound. Okay. All right, so I've got my table in there. And again, folks, you can plot those ordered pairs, or we can set up our scale first. So I don't want to jump ahead before we graph. Okay. I apologize, folks. I grabbed the wrong equation. That was for the first one, so I apologize. Let me clear that one out. Sorry, guys. Live video, let's try that again. So if I go to y equals, I got to go to the graph. Sorry, to the table. Okay, and I need the y2 values. So I'm going to ignore the y1. So why don't I just go to y equals and get rid of that for a second? So I'll just go like this and enter it. And hopefully this will help me with my table. There we go. Okay, so I apologize about that, guys. Let's try that again. Okay, so we go to our graph. That looks better, guys. Okay, so now we notice, folks, looking at our table of values, we scan down and look for the turning point. Notice we've got 11, 6, 3, 2, 3, 6, 11. So my turning point is here, and that's going to be your vertex, okay? So what I'm going to do is I'm going to start plotting the point on my vertex, because everything changes about the vertex. And then I'm going to use my step pattern. My step pattern is still 1, 3, 5. Why is it? Because a is still equal to 1. So from there, I'm going to do the same patterning. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, do the same thing on their side. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, draw your parabola as best as possible and label it. Okay, so what do we notice, folks, is that when we add 2 to the end of it, it actually makes the graph go up 2. All right, so let's answer some of these questions. What is the vertex? The vertex is 0 and 2 because it pushed it up. The direction of opening is still up. What's our step pattern? It's going to still be up 1, up 3, and up 5. Any questions there, folks? All right, next one. Take a look at investigation number 2. We noticed our equation is x squared minus 3. What do you suppose the negative 3 is going to do this time? It's actually going to bring it down 3. Good. But notice a is out front and it's still 1, right? Attached to x squared. So let's go to y equals. Change our equation to minus, so subtract 3 and press graph. And notice it goes down below. Okay? Any questions there, folks? All right, let me just quickly steal the table while I'm here. Bring it over. Okay, so taking a look at our table, ladies and gentlemen, we notice that we have, did I do that again, the wrong one? I apologize. I don't know why I didn't get the one from, I apologize, guys. Here, sorry, second graph. I took the wrong table again. Sorry. I'm going to try to fix that later on. Ha 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 ha, now I'm in trouble. Okay, we'll try that. Try that again. So, table. Over here. Now we should be set. Let me bring that one. Let me bring that one down here and replace it. Sorry, guys. I'm trying to use technology, and sometimes it gets confusing, but we're good here. All right, so taking a look at our table, folks, okay, we notice that we got 6, 1, -2, -3, -2, 1, 6. So you look for the turnaround point. That automatically tells us our vertex. So we can circle, put in our vertex, which is there, of 0 and -3. Okay, in this case, A is still 1, so we're still going to have the same step patterns. So to get started, we're going to label our axes. And here we go. So my ordered pair for my vertex is 0 and -3. So I start there. And from that, I do the same step pattern because A is still 1. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay, same on the other side. Over 1, up 1. Over 1, up 3. Over 1, up 5. Okay. And there we go. Okay, and then we got y equals x squared minus 3 for our label. Okay, and so the effect of that is it pushed it down 3. Okay, the direction of opening, folks, is still up. Our step pattern is still up 1, up 3, up 5, and that will change eventually, but not for a little while. Now we have a question to ask here. What does the effect of a number being added or subtracted at the end of the basic parabola? And that's going to be a vertical translation. So you're either shifting up or down. Okay? So up if positive. And down if negative. Okay, and the letter we're going to use for that one, that's going to be our Q. That's the second part of our ordered pair of our vertex. Okay? All right, let's flip to the next page and take a look at investigation 3. Okay, so for investigation 3, we're changing it up. Now we've got a number inside the brackets that it's raised to the exponent. Notice also that the number in front of the bracket is still 1, so A still equals 1, so our step pattern is still the same. But I wonder what this effect will do when you're adding or subtracting a number into the brackets. Okay, I just want to quickly remember that vertex form that we wrote down before from last class is y equals x minus p squared plus q. So the negative part is the formula. So the negative is there, and then the p in this case is going to be 3. So p equals 3 in this case. And that's going to change which direction we go. So we've already explored about going up and down. What do you think this is going to be? I think it's going to be a left and right translation, but we can use the graphing calculator to prove it. So go to y equals, down, opening bracket, x minus 3, closing bracket, squared. Okay, let's graph and see what's happened here, guys. Aha, it shifted 3 spots to the right. Okay, so I'm going to do this correctly this time. I'm going to get the table from here, and I'm going to borrow it and take it into our lesson. Well, let me go to the lesson. There we go. Okay. Okay. Now, that would be great. However, I forgot to look at my ordered pairs where I should be starting. I should be starting at 0, not at -3. So I'm missing some of them. So I'm actually going to just delete that one, go back to my graph, and I'll show you how to fix that. So I'm going to go up until I get, or sorry, down until I get 0 at the top where I wanted it. Now I got the data that I wanted, okay? So I'm going to now select it. Okay. So I bring that in. Now we're looking better. Okay, so taking a look, ladies and gentlemen, we still have a change. You might recognize these numbers, though, 9, 4, 1, 0, 1, 2, 4. However, the x values are different. You should still notice the switch around is here. Okay, all right. And that, in fact, is our vertex. So we can get ready to plot that. Okay, so I'm going to start with 3 and 0. And because A is 1, I still do my same step pattern. Over 1, up 1, over 1, up 3, over 1, up 5. If you're saying, Miss R, I'm getting annoyed by the step pattern, I want it to be in your short-term memory, and I want you to be able to have it in your long-term memory. So if it's annoying, awesome, because then you'll remember it. Okay? Because it is the easiest way to graph parabolas. I'm going to put our equation down, y equals x minus 3 squared. Okay? So what do we notice, folks? P equals 3, and it made us move to the right 3, the vertex, okay? So our vertex, folks, is 3 and 0, and remember, that's your ordered pair, P and Q. So that's why another reason why we're dealing with P here. Direction of opening is still up. Okay, step pattern is still up 1, up 3, and up 5. And I know you're saying, Miss R, I'm getting bored of that, but it will change on the last page. Okay? All right, so the next thing we need to take a look at is our equation here. Again, A is still 1, okay? But it's x plus 4. Our equation is always x minus p squared. But how does a negative automatically become a positive? The p-value has to be a negative. So a negative times a negative gives that positive value. So p has to be negative 4 in this case. Okay? So that's going to shift it the other way 4. And let's use the graphing calculator to prove us on that one. Okay? So we're going to go to this one and y2, change it to plus 4, and we're going to graph it. Okay, and indeed, it's shifted 4 spots to the left. Now, before I select my table, I want to make sure I've got the right data point at the top. So we need -7 this time. Okay, so I'm going to borrow that. Tap it in. Okay, and again, taking a look, ladies and gentlemen, at your table, you should recognize your vertex is the turnaround point. So our vertex is -4 and 0. Okay, so I'm going to get my scales on my axes. Let's try to do it right, Miss R. There we go. I know, live video, isn't it fun? Okay, and we're going to start by plotting -4 and 0. Okay, and A still equals 1, so it's still same step pattern. You should have this down pat by now. Over 1, up 1. Over 1, up 3. Over 1, up 1, 2, 3, 4, 5. Same on the other side. Over 1, up 1. Over 1, up 3. Over 1, up 5. And draw your graph of your parabola. And label it y equals x plus 4 squared. Okay, so keep in mind, the P is kind of opposite in the bracket. So although it says plus 4, the formula is negative itself. So it's the opposite of what it appears in the bracket. That's a little trick. Okay? Direction of opening, folks, is up. Step pattern is still the same. So up 1, up 3, and up 5. Okay? Now the question asks, what is the effect when a number is added or subtracted in the brackets of the equation? Well, first of all, we're dealing with a horizontal translation, so left, right. Okay, and we're going to say when P is greater than 0, it moves to the right. Okay, but in the example, it's going to look like x minus 5 or something. Okay? It's still, the negative is part of the formula, so this is your p-value. Okay? The other one is if p is less than 0, you're going to moves to the left. And the example of that, it's going to be backwards. It's going to be like x plus 3 squared. Because a negative times a negative gives you that positive. Okay? So just to make sure you realize, this is p equals 5 in this example here. And this is p equals negative 3. Okay? Because a negative times a negative give you that positive. Awesome. So we've taken our parabola. We've learned how to shift it up and down, left and right. Now we're going to do some stretchy stuff or do some shape changing. This is exciting. Let's keep going. All right. So now we're taking a look at the letters out front. Now, folks, A is changing. A is no longer 1. A equals 0.5. So that affects our step pattern. So normally we do A times 1, 3, 5. We now know that A is not 1, so it's 0.5 times 1, 3, 5. So what is half of 1? It is 1/2. What is half of 3? 3 over 2. And what is half of 5? 5 over 2. If you don't like fractions, ladies and gentlemen, you can change that to 0.5, comma 1.5, comma 2.5. Either or is fine. Okay, so those are going to be our steppings. Okay, let's get this graphed up on our calculator here. So go to y equals, if I put my pen down, it'll help me. Okay, clear that off. Go to y2, and I'll change that to 0.5 x squared, and just delete that second one. Okay, press graph. Now, ladies and gentlemen, that might look normal, but I'm going to go back to y equals, and I'm going to turn on my first graph, just so you can compare from the regular one to the new graph. Okay, so the original one is the thin line, so that's your basic parabola. And what's happened to our new parabola is it's gotten wider. Okay, so when A is between 0 and 1, either a fraction or a decimal, it's going to make things wider. Why is that? Because the step pattern is less. Okay, so let me just go to y equals for a second and clear that so we don't have that showing up on our table. Okay. Okay, let me grab our table values. What values do I want? -3. I'm going to just move this over for a second. Get -3 up. Okay, and we can snap it now. Hope that isn't so loud on your video. It's pretty loud when it comes in my ears doing those snaps, so hopefully you're okay with that. All right, so taking a look, ladies and gentlemen, at our table values, look for the turning point again. Our turning point is 0, 0, which is our vertex. Okay. Now our step pattern changes, finally. So watch this carefully, please. As I go over 1, instead of going up 1, I'm going up 1/2. Okay? As I go over 1, instead of going up 3, I'm going up 1.5. And as I go over 1, I'm going up 2.5. So it's getting wider than it used to be. Same on the other side. Over 1, up 1/2. Over 1, up 1.5. And over 1, up 2.5. So it's wider. So I've compressed it. Okay, think of flattening a pancake almost. Now the equation is y equals 0.5 x squared. Okay, so our vertex is 0, 0. Direction of opening is still up. But what is our step pattern? As we go over 1, we go up 0.5. As we go over 1, we go up 1.5. As we go over 1, we go up 2.5. All right. Okay. All right. Last investigation. This is going to be the fun one. I love this one. Well, look at A, for example. In the equation, A equals -3. So the 3 part we can apply to the -3 part we can apply to the step pattern. So -3 times 1, 3, and 5. So that's going to be -3, -9, and -15. What do you suppose the negative means? Instead of going, when I go over 1, instead of going up 1, what do you think is going to happen? I'm actually going down 3. So this is where we're actually going to flip this upside down. This is going to be cool. Ready? Let's take a look. So let's just get this on. So I'll show you the original one plus the new one, which is going to be -3x². Okay, let's try graphing it. So here's my original, and then look what happens. I flip it, but what also happens is it's more narrow, so I'm stretching it. Isn't that cool, guys? All right, let's go to y equals. Let me get rid of that equation so it's not going to bug me. Let's grab the table, bring it over. Almost done, guys. Okay. Now, obviously, looking at this, folks, with the step pattern being so big, we got some numbers that we won't even be able to fit on our graph. That's okay. All right, so notice our graph looks different. We still have to realize that this is my x-axis and this is my y-axis. Did I remember to do? Oh, look, Nassar forgot that on the last one. So can you please go back and put those up? Sorry, guys. Okay, and then I get so excited about graphing, I forgot my communication there. Okay, so I label my axes, and now I'm going to look for my vertex. So my turning point here is 0, 0. And now I got to follow my step pattern. As I go over 1, I'm going down 3. Over 1, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we won't be able to do the 15 because it's too far. So on the other side, over 1, down 3. Over 1, down 9. And look how narrow it is. So we've stretched it. Okay. All right, and we call that y equals -3x². So when a is negative, that flips it upside down, which makes the direction of opening down, which we can fill in there. Okay. And our vertex, ladies and gentlemen, is 0, 0. But let's take a look at our step pattern. As we go over 1, we go down 3. Over 1, down 9, and over 1, down 15. Okay, and hopefully you have this written down so you can easily see that. All right. What is the effect of the positive or negative number that is multiplied to the equation out front? Well, there's two things we've got to take a look at. Try to fit this in. So there's the sign of it. So if a is greater than 0, or positive, so if a is positive, here's my short form for a is positive, that means the direction of opening is going to be up. But if a is negative, there's my short form for negative, then it's going to open down. So that's direction of opening. That's based on the sign. Okay? Whereas the number itself, or the value, is either going to do a stretch or compression. So based on the step pattern, we will have a stretch if a is greater than 1, okay? And it will be a compression, so stretch, which means it's getting narrower. Okay, so this deals with the shape of the parabola. Or a compression if a is between 0 and 1, okay? That means it's going to get wider. So we've dealt with A's, P's, and Q's. All right. Now it's hard to assign homework with the graphing calculator because we don't have them at home. So I'm going to quickly go over one of the handout properties. This I'm going to show you how to do it based on the equation. So flip over to your homework and I'll help you get started with this. First thing I want to do is write in some topics up top in the titles to help us. So first of all, folks, the equation of vertex form is y equals a x minus p squared plus q. This is a really good question to have on your unit test, so make sure you study for this. The vertex, as we should have learned, is p and q. Okay? The step pattern we learned today is a times 1, 3, and 5. And the direction of opening depends on if a is greater than 0, or positive, or If it's negative, A is going to be less than 0. Okay, and it's going to open down. All right, so let's take a look at these examples. So for the first one, we're looking for the P and the Q. Remember, P is what's left over after there's a negative. So the negative is part of the formula. So in this case, P is 2, and Q is the number at the end, which is 1. So what does that tell me? It tells me I'm going to shift 2 to the right and 1 up. Okay, if I was asked to describe that. Step pattern, A is what value, folks? A equals 1, so that means it's just going to be 1, 3, and 5. Direction of opening, A is positive, so it opens up. We'll try one more, and then we'll let you try the rest on your own. Okay, taking a look here, folks, A is what's in front. There's a negative out front, so A equals negative 1. That's going to change your step pattern and your direction of opening. But let's go in order here. Let's deal with our vertex. Please be careful here. It's x minus p in the formula. So in order for a negative to become a positive, the p had to have been negative to begin with. Okay, and then we are going to have Q is 6. What does that mean? If we're shifting this around, it means it's going to go to the left 4 and up 6. Step pattern is going to change because A is negative 1. So if you want to fit that in, negative 1 times 1, 3, and 5, that's going to equal negative 1, negative 3, and negative 5. Okay? Direction of opening looks at A. A is less than 0, so it's going to open down. All right, so ladies and gentlemen, I want you to fill in this chart. I also want you to sketch A on this page and B, example B and I. So A on the first page, B and I on the back side of this sheet to practice some sketching. All right, have a great day. Thank you for the long lesson. Hopefully you understand how to do this with the technology. And again, we can get the graphing calculators out in class and we can practice doing this if you need help. All right, thanks, have a great day, and I'll see you soon.